Hello there students, good day. Welcome to another mathematics tutorial. In this video, we're going to solve some problems involving patterns and sequences. If you're new to this channel, please subscribe and don't forget to hit the notification button for upcoming videos. This is SirJan, and without further ado, let's get started. Number 1, which of the following set of numbers shows a pattern? Now let's examine each choices. For letter A, the first term is 1, the second term is -1, and the third term and the fourth term are the same with the first term and the second term. Thus, we can predict the next term of the sequence, like this one. The fifth term will be 1, and we can predict that the next term, the sixth term, is -1. However, in the choices B, C, and D, it does not show a pattern since it is not possible to predict the next terms of the sequence. Next question, which of the following numbers is the 14th term of the sequence with its nth term a sub n equals 2n over 4? In this type of problem, the given is the general rule of the sequence, which is given by a sub n equals 2n over 4. Then we are asked to find the 14th term, or the a sub 14. Thus, n is equal to 14. Now let us find a sub 14 by substituting n equals 14 in the formula a sub n equals 2n over 4. Thus, we have a sub 14 is equal to 2 times 14 over 4. It will give us 2 times 14 is 28 over 4. Therefore, a sub 14 is equal to 7. So here is our answer. Therefore, the 14th term of the sequence with its n term a sub n equals 2n over 4 is letter B, 7. Next question. Which of the following numbers is a term of the sequence given by a sub n equals 6n minus 3? To answer this problem, we need a value of a sub n, in which when we're going to substitute to a sub n equals 6n minus 3, it yields to a value of n must be a whole number, meaning it is not a fraction. So let's try letter A. If a sub n is equal to -1, we got -1 is equal to 6n minus 3. We have -1. We are going to transpose -3 to the left side. -1 plus 3 equals 6n. We get 2 equals 6n. Divide both sides by 6. So we got 1/3 is equal to n. So this is a fraction. Therefore, -1 is not a term on this formula a sub n equals 6n minus 3. Let's try letter B. If a sub n is equal to 1, we get 1 is equal to 6n minus 3. Transpose -3 to the right side. We get 1 plus 3 equals 6n. 4 equals 6n. And divide both sides by 6. So we got n is equal to 2 over 3. Still, 1 is not a term on the sequence. So let's try another. If a sub n is equal to 3, so we get 3 equals 6n minus 3. Transpose -3 to the left side. So 3 plus 3 equals 6n. 6 equals 6n. Divide both sides by 6. So we got n is equal to 1. So this is a whole number, meaning to say that 3 is a term on the sequence. But let's try letter D. If a sub n is equal to 6, so we get 6 is equal to 6n minus 3. 6 plus 3 equals 6n. 9 over 6 equals 6 over 6n. N is equal to 3 over 2. So the only value of a sub n that will make n a whole number is letter C, 3. Given the terms of the sequence 1, negative 1, negative 3, negative 5, give the next three terms. By looking at the sequence, it is in descending order. The first term is 1, followed by negative 1, negative 3, negative 5, and so on. Thus, the rule should be adding a negative number to each term. Thus, by looking at the term 1, negative 1, negative 3, negative 5, from 1 to negative 1, we are adding what number? Right, that is negative 2. And from negative 1 to negative 3, another negative 2. And from negative 3 to negative 5 is negative 2. If we're looking for the next three terms, we need to say terms after negative 5. We can solve this by adding negative 5 by negative 2, which yields to negative 7. And that is the first term after negative 5. Now let's have negative 7 plus negative 2 is equal to negative 9. And let's have negative 9 plus negative 2 is negative 11. So these are the three terms after negative 5. So the answer is that's letter D. Alright, so that's how you're going to solve for this type of problem. What are the next two numbers that will complete the sequence 100, 121, 144, 169, 196, 225, blank and blank? Now notice in the sequence, each term of the sequence are perfect square. 100, 121, this 225, these are called perfect squares because each term can be expressed into x squared. This term can be written as, let's say, 100. 100 can be written as 10 squared, right? 11 squared is equal to 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 225 or 15 squared is 225. So this is the pattern. By looking at this pattern, we can predict that the next number could be 16 squared and 17 squared. 16 squared could give us 256 and 17 squared could give us 289. So therefore, the next two terms after 225 is 256 and 289. So the answer is letter A. That's how we're going to solve that type of problem. Okay, let's have the next problem. Which of the following set of numbers is the first four terms of the sequence defined as a sub n equals n squared plus 3n minus 5? We're going to solve for a sub 1, a sub 2, a sub 3, a sub 4. And to do this, let's substitute n is equal to 1, n equals to 2, n equals 3, and n equals 4 to this formula. Now let's have a sub 1 is equal to 1 squared plus 3 times 1 minus 5. We have 1 plus 3 minus 5. The answer is negative 1. Let's have a sub 2 is equal to 2 squared plus 3 times 2 minus 5 equals 4 plus 6 minus 5. 4 plus 6 is 10 minus 5. So the answer is 5. Let's have a sub 3. 3 squared plus 3 times 3 minus 5 equals 9 plus 9 minus 5 equals 18 minus 5. The answer is 13. Now let's have the a sub 4, or the fourth term. We have 4 squared plus 3 times 4 minus 5, which gives us 16, plus 12 minus 5 equals 28, minus 5 will gives us 23. Therefore, the first four terms of the sequence are negative 1, 5, 13, and 23. So the answer is letter B. Now let's have next questions. Consider the general term of the sequence a sub n equals n squared plus 8. What are the first three terms of the sequence? So just like the previous problem, we're going to find the a sub 1, a sub 2, and a sub 3. Now let's substitute the value of n to the formula n squared plus 8. A sub 1 is equal to 1 squared plus 8. So it will gives us 1 plus 8 is 9. Let's have a sub 2. A sub 2 is equal to 2 squared plus 8. That's 4 plus 8 equals 12. A sub 3 is equal to 3 squared plus 8. That's 9 plus 8. So the answer is 17. Therefore, the first three terms of that sequence are 9, 12, and 17. And that's letter A. In what term of the sequence is 233? So in this type of problem, we are going to solve for the term number or the value of n. Since the given is a sub n equals 233, let's substitute this to the given formula. So we have 233 is equal to n squared plus 8. So we got transpose 8 to the left side. We get 233 minus 8 equals n squared. 233 minus 8 will give us 225 equals n squared. Now let's continue here. We're going to extract both sides since 225 equals n squared can be interchanged. So we get n squared equals square root of 225. So we have n is equal to 220, square root of 225 is 15. So therefore, this 233 right here is the 15th term of the sequence a sub n equals n squared plus 8. Which of the following numbers is the ninth term of the sequence? So in this type of problem, so the ninth term, the given was the n is equal to 9, and we are going to find the value of a sub n. So to do this, let's substitute the value of n to this formula. We got a sub 9 is equal to 9 squared plus 8. So that's 81 plus 8, and will give us 89. And that's letter C. Thank you, dear students, for listening, and I do hope you were able to grasp some understanding on different problems pertaining to pattern and sequences.